Good morning, dear students. My name is Ferhan Mazher, and today is 26th February 2021. The day is Friday. Right now, I am with the 11 Cambridge class. We also call it O3. The subject we are studying is Physics 5054. And today we are going to do May June 2015 2-1 paper. It's a theory paper. We call it paper 2. And in this session, we will be attempting its section B only. That section B starts from the question number 9. So let's start. The first question is figure 9.1 shows a satellite in orbit around the Earth. The satellite travels at a constant speed in a circular orbit. Underline the quantities. Underline the quantities in the list below that are scalar. So what do you think? Which quantities are scalar?
Mass, speed,
Speed is a sorry. Uh, these acceleration is a vector, force is a vector, velocity is a vector. So the mass and the speed, they both are scalar. He asked us to underline the scalar. So underline mass and speed. Acceleration, force, and velocity, they all are vectors. They have directions. You understand? We have to underline scalars.
yes, sir.
So mass and speed will be the scalar quantity. This was a 2-mark question. Look how easy this is. The velocity of the satellite changes, but its speed is constant. State what is meant by velocity. Velocity means the rate of change of displacement. The definition of the velocity is the rate of change of displacement. 1-mark definition. Kindly write this in your booklet. Rate of change of displacement, or you can say displacement divided by time. On your screen, the marking scheme is also showing. Once you are written, kindly let me know.
Yes, sir, done.
Okay. So next question is explain why the velocity changes. Although he said that you can look at here, he said the speed is constant. The speed is constant. It means the magnitude of the velocity is not changing, but still the velocity is changing. Why? Because the body is moving in a circular track or circular path. Whenever you move in a circular path, your direction is changing, and the velocity is constituted by magnitude and the direction. The magnitude, no doubt, is not changing; it's constant, but its direction is changing. That's why we say that the velocity is changing. So the velocity is changing basically because the direction of the motion is changing at every instant. So kindly write this. On your screen, you can see that marking scheme. Kindly write this answer. And once you have written, kindly read this that answer also.
Velocity changes due to change in direction of motion.
Yeah, change in the direction of the motion because the thing was traveling in a circular path. Okay, so we are done with this. Okay, this was 1-mark question. Explain what makes this satellite move in an orbit that is circular. When the satellite is moving in a circular orbit around the Earth, it will need centripetal force. And that centripetal force is provided by the gravity of the Earth, the gravitational pull of the Earth. or gravitational force of the Earth? So this is a 2-mark question. Let us check the marking scheme as well. The force of gravity from towards the Earth, force is centripetal or at right angles to the motion of velocity. Yes. So Muskan kindly right. To move in a circular path, we need centripetal force, and that centripetal force is provided by the gravitational pull of the Earth, or gravity of the Earth. If you have written, kindly read your answer also, so we can check. 1 mark is for mentioning the gravity, and 1 mark is for mentioning that it's a
Done.
centripetal force.
Done, sir. So I have written when satellite move in a circular path, it
Yeah,
needs centripetal force, which is provided by gravitational force of Earth.
very good. You get full 2 marks. Okay, the next part, B part of the question number 9, May, June 2015, 2-1 paper. The satellite is placed into orbit by a rocket. Figure 9.2 shows the rocket as it takes off. The rocket and fuel have a total mass of 40,000 kg and a total weight of 400,000 Newton. The resultant force acting upwards on the rocket is 50,000 Newton. Calculate the thrust produced by the rocket engine. Okay, so you see the thrust which the engine should produce, it should overcome this weight, plus it should provide this upward force. So the engine should provide in the force to overcome the weight, plus the engine should provide the force for the upward motion. So you can find, right? Let me show you here. So the force provided by the engine, the force which is provided by the engine, that will be thrust produced by the engine. Thrust is equals to the weight. It has to overcome the weight. It has to overcome the weight, plus it has to provide the upward force, resultant force. Okay, so you have your calculator with you. The weight is 400,000 and the resultant force is 50,000. So what will be the answer? You have calculator with you?
Yes, sir.
450,000 Newton. So you see, you understand this?
Yes, sir.
Okay, so we are good. It was 1 mark question. Then the next question is calculate the acceleration of the rocket. The acceleration can be found by Newton's second law, which says F equals to ma. The mass of the rocket is, how much is the mass of the rocket? 40,000 kg. That's 40,000. And you multiply it with the acceleration. I want to know the value of the F. I know the resultant force is given. In this formula, we always use the resultant force. So the resultant force is 50,000. Okay. So if you want to find out the value of the A should be made alone on one side. So it will be something like 50,000 divided by 40,000. So get me the answer. Do you have your calculator with you?
1.25.
1.25, and it will be meter per second square. Muskan, do you understand? We have used the second law of motion. F is equals to ma. Its mathematical form is F is equals to ma. The mass we know, and we also know the resultant force. The resultant force was 50,000 Newton, and the mass was 40,000 kg. And this is how we found the acceleration.
Yes, sir.
Okay. Then the next question. Let's check the answer also. If our answers are good. You can see on the marking scheme is showing on your B first part and second part. Our answers are perfect. Okay, the next thing. In the first 4 minutes after takeoff, the acceleration of the rocket is uniform. State what is meant by a uniform acceleration. Uniform acceleration means that there is equal change in the velocity in equal intervals of time. If there is an equal change in velocity in equal intervals of time, we say that the acceleration is uniform. It's a 2-mark definition. Marking scheme is also showing for the C first part that the same change in velocity, 1 mark for saying this, and 1 mark is for saying that in the same time period. Equal change in velocity in equal intervals of time, the acceleration of the body will be known as uniform acceleration. Once you are done with writing, kindly let me know.
Done, sir.
Yes, what you wrote.
I have wrote equal change of velocity in equal interval of time is uniform acceleration.
If there will be equal change in velocity in equal intervals of time, the acceleration of the body is known as uniform acceleration. Okay. So the next question, figure 9.3 describes the motion of the rocket in the first 12 minutes. He says from 0 to 4, there will be uniform acceleration. From 4 to 6, increasing acceleration. From 6 to 10, decreasing acceleration. And from 10 to 12, there will be a constant speed. So he says on figure 9.4, sketch the speed time graph of the rocket for the first 12 minutes. Okay, so let me copy it from here and take it into the paint. Okay, so here we go. So let me draw some lines so it will become very easy for you. I am just drawing lines to I'm just trying to make a grid, okay? This is not the graph, okay? I'm just trying to make a grid so it becomes easy.
Okay, sir.
I'm working with the mouse, that's why my lines are not that accurate, but you can draw very accurate lines. I am just drawing this grid so that my work is perfect. You see, you need to show passion for this work. With all love and care, you have to draw these lines if you want to get full marks. Okay, now we will draw the whatever he said. He said, let me, from 0 to 4 seconds, there was a uniform acceleration. Whenever there is a uniform acceleration, we represent it with a straight line. So that is represented from 0 to 4, I think he said, from 0 to 4, uniform acceleration. Uniform acceleration is represented with a straight line. So let me show it with a straight line. From 0 to 4, it was moving with a uniform. Okay. So I will draw a line like this. A straight line shows on the speed time graph, it means that the body is moving with the uniform acceleration. Okay.
Then 4 to 6 increasing acceleration.
This you read. Okay. So from 4 to 6, increasing acceleration. On the speed time graph, when you represent increasing acceleration, you draw a curve which is curving upward. From 4 to 6, you said?
Yes, sir. From 4 to 6 increasing acceleration.
Okay. So this is the increasing acceleration. So I have not drawn that good curve, but this is the curve which is curving upward. Okay. It means the acceleration is increasing. Okay. In the next part,
6 to 10 decreasing acceleration.
then the acceleration, the speed is increasing, but the acceleration will be decreasing. You see this curve, its gradient is gradually decreasing. The new curve which I've drawn there from 6 to how much?
10.
6 to 10. Oh, sorry. 6 to 10. Let me draw it again. From 6 to 10. So I will draw a decreasing curve. So you see this is the decreasing curve. Okay. This is decreasing curve. Its gradient is gradually decreasing. Then
10 to 12 constant speed.
the constant speed is represented with a horizontal line on the speed time graph. This should be like this. Do you understand?
Yes, sir.
Uniform acceleration was on the speed time graph is represented with a straight inclined line. The increasing acceleration is represented with a curve curving upward, and with its gradient is gradually increasing. I represented with the green curve, and the decreasing acceleration from 6 to 10, that is represented with a curve which is whose gradient is gradually decreasing, and the zero acceleration or constant speed is represented with a horizontal line. I hope that you have understood this. Muskan, you have understood this?
Yes, sir. Yes, sir.
Have you drawn this on your paper?
Yes, sir.
Okay, so it's good. We can move to the next question. So you see, this was a 3-mark question, an easy one. If you have the concept, then it's easy. You can get these 3 marks easily. Okay, the next part is state how the speed time graph in the figure 2 can be used to find the distance traveled by the rocket. What you say? How we can find the distance traveled?
Area under speed time graph.
Yes, the area, if we calculate the area under the speed time graph, that area under the speed time graph represents the distance traveled. Let me show you the marking scheme also. Area under the graph. He said area under the graph. You get the 1 mark. So that was question number 9. I hope that everybody has understood this question. It looks very easy question, and I hope you can get all the. I think it has 15 marks, so I think that you can get all the 15 marks out of it. Okay, so we will move to the next question. Okay. The next question is question number 10. This is summer 2015 paper. The number of the paper is 2-1. This is zone 1 theory paper, paper 2. And we are doing it section B. We are on the question number 10. A student makes a diagram of the molecules in liquid as shown in the figure 10.1. Suggests two ways in which the student's diagram does not show the positions and motion of the molecules accurately. He was trying to draw the molecules of the liquid. So we have to show, we have to describe, or we have to test two ways in which we can argue that these are not good representation of the molecules of a liquid. So, for example, they are arranged in a regular pattern. If you look at the diagram, he has arranged the molecules in a regular pattern. That is never the case with the liquid. The molecules of the liquid cannot be arranged in a regular pattern. Another argument can be that the molecules, he has, with the help of the arrows, he has shown that the molecules are kind of vibrating, and they all of them, they are vibrating in the same direction, which cannot be the case in the liquid. In the liquid, the molecules are moving randomly, and they move in all directions, and they have different velocities, and they move randomly, and they move in all directions. So you see, at least I have mentioned two arguments in which we can say that, or we can suggest that these molecules are not a good representation of the liquid molecule. Let me show you. This is a 2-mark question. Let us check the marking scheme as well. You see, this marking scheme is showing on your screen. He says the liquid molecules not arranged so regularly. That can be the one argument. And the liquid molecules not vibrating. Liquid molecules do not vibrate. They move. Plus, he has shown that they are moving in the same direction. That's wrong. Or do not have the same speed. The molecules in the liquid, they have different speeds. Muskan, can you write two suggestions that why this is not a good diagram to represent liquid molecules?
Yes, sir, I have written. I have written that molecules are arranged in a regular pattern. And secondly, I have written that molecules shown are moving in same direction.
Okay. So in the water or liquid, okay. So B part, some of the molecules of a liquid evaporate. Describe what happens during evaporation. So during evaporation, what happens? You see the molecules with higher kinetic energy. They come to the surface of the liquid, and from there they go into the air. Okay, the molecules which have higher kinetic energy, and they are able to overcome the intermolecular forces and overcome the atmospheric pressure. They leave from the surface of the liquid. It's a 1-mark question. Describe what happens. Okay, so let me check the marking scheme also. He says molecules liquid escape from the surface, and they break bonds. Yeah, they overcome intermolecular forces, they break their bonds with other molecules, and they go into the air. Muskan, write your answer, beta.
Then, sir, I have written that molecules with higher kinetic energy they escape from the surface of liquid.
Yeah, that's good. The next part is explain why evaporation has a cooling effect on the liquid. Whenever the evaporation happens, the liquid which is left behind, its temperature drops. We have to explain why this happens. You see, the molecules in the liquid which have higher kinetic energy, they leave from the surface. That argument we have already done. So the molecules which are left in the body of the liquid, they have lower kinetic energy. Due to this, you see the average kinetic energy of the liquid molecules will drop. So when the average kinetic energy drops, the temperature of the liquid will drop. This causes the cooling effect. You see, he says there are two marks. He says fast moving or more energetic molecules evaporate or escape. One mark for saying this. And leaving slow molecules or molecules with the less kinetic energy on average. Muskan, kindly write your answer, bete. It's a 2 mark question.
Done, sir. I have written that molecules which are left has lower kinetic energy. Average kinetic energy of liquid drops, thus temperature of water also drops, giving cooling effect.
Okay. The molecules which are left in the liquid. Okay. You see, whatever word you use, whatever verb you use, whatever noun you use, it should be very clear that you are talking about what. Okay.
Yes, sir.
Let's move to the next part. Okay. Here we have the beaker shown in the figure 10.2 contains pure water at a temperature of 80 degrees centigrade. A thermometer initially at room temperature is placed in the air just above the water. The reading on the thermometer starts to increase slowly. Explain how, explain how convection in air causes the reading on the thermometer to increase. Okay, so what will happen? You see what will happen. The the air here, which is in contact with the surface of the water, the air here will absorb the thermal energy, and this air molecules, they will move away from each other, and the air will become less dense. So this air will rise upward, and the cold air will come down. So the convection currents will be set in. So when that hot air, when it's going upward, when it comes in contact with the bulb of the thermometer, you see what will happen. Uh, it's when it comes in contact with the thermometer, it will give its energy to the thermometer. So that's why the mercury in the thermometer will rise. Let me check the answer. It's a 1 mark question. He says hot air rises. He just wrote hot air rises. So kindly, Muskan, write your answer. 1 mark question.
Okay, sir. Done, sir. I have written when hot air rises, it comes in contact with thermometer, making mercury in the thermometer to rise.
Okay. The second part is a heater is placed underneath the beaker and the water boils vigorously to produce steam. The thermometer reading increases quickly. Explain how the water in the gas state gives thermal energy to the thermometer. You see what happens, that when the water starts boiling, the steam or the water vapors, they are rising upward. So and when they are rising upward, they come in contact, that steam comes in contact with the thermometer. And when that steam or gaseous water that come in contact with the thermometer, the temperature of the thermometer is lower as compared to the temperature of the steam. So what will happen, the steam will stick to the surface of the thermometer, and the steam will condense, the steam will convert back into liquid. When it will convert back into liquid, it will give its energy to the thermometer. And when the energy will be given to the thermometer's temperature will rise, and the mercury will quickly rise. Do you understand what I said? Let's
Sir,
check.
can you please tell me again?
You see on your marking scheme, it says the steam condenses or changes to liquid on thermometer, or heat conducted from hot to cold, gives out latent heat to the thermometer, and or explanation involving bonds being made. Okay. So there are two marks. You see the steam is coming out from the boiling water. And when that steam will come in contact with the thermometer, on the surface of the thermometer, that steam will condense. It will convert into liquid. You see, for example, when you put a lid on a utensil in which we have a boiling water, on the bottom of that lid you will always find water, because when the steam comes in contact with another object like the thermometer or the lid, that steam will turn back into liquid. We say the condensation has taken place. So when that condensation takes place, you see the latent heat, of vaporization is given out by the steam. The latent heat of the steam is given to the thermometer, and the mercury in the thermometer will rise upward. What do you say?
Yes, sir.
Kindly write this answer. Let me see how you have written. Shabash, shabash, shabash. Shabash, shabash, bete. Kindly write your answer.
Done, sir.
Okay, what you have written.
I have written that steam rises up and steam comes in contact with thermometer and it condenses. Latent
Okay.
heat of vaporization is given out to thermometer by steam, making mercury in thermometer to rise.
Yes, that's right. The steam will condense on the surface of the thermometer. You understand?
Yes, sir.
Let's move to the next part. The next part is, Muskan, will you like to read the question?
Yes, sir. The heater placed underneath the beaker has power of 200 volts.
Okay.
The mass of water in the beaker is initially 100 grams. The water in the beaker is heated for a time of 120 seconds. During this time, the temperature of the water in the beaker rises from 80 degree to 100 degrees Celsius, and then the water boils. At the end of this time, the mass of water in the beaker is 95 grams. The specific heat capacity of water is 4.5 joules. The specific latent heat of vaporization of water is 2250 joules per gram. Calculate the thermal energy heat produced by the heater in 120 seconds.
Okay. So the energy is equals to power multiplied time. Energy is equals to power multiplied time. The power of the heater is 200 watt and the time is 120 seconds. Just write the formula. Energy is equals to power multiplied time. 200 watt multiplied 120 seconds, and your answer. Get the answer. You have your calculator.
24,000 is answer.
Joules. The unit is very important.
Yes, sir.
So what you said? What you said?
24,000 joules.
Oh yes. Let me check the marking scheme also. 24,000 joules is the right answer, ma'am. Okay, the next part. Yes. used to warm the water from 80 degrees centigrade to 100 degrees centigrade. Whenever you want to calculate the amount of heat for raising the temperature, we use the formula heat is equals to mc delta theta. M is the mass, C is the specific heat capacity of the water, delta theta means the change in the temperature. You see the mass of the water is 100 gram. The C, the specific heat capacity of the water is 4.2 joules per gram per degree centigrade. And the change in the temperature is from 80 to 100. So it will be something like 20 degrees centigrade. The change is 20 degrees centigrade. Just put the values, multiply each of them with each other, and you get the answer.
8,400.
8,400 joules.
Yes,
Mentioning
8,400.
mentioning of the unit is very, very, very important. You are always supposed to mention the unit. But do you understand this?
Yes, sir.
Whenever there will be a change in the temperature, the heat involved during that time is mc delta theta. You understand?
Yes, sir.
Okay, the next part. He says the heat which is used to reduce the mass of water in the beaker. Let me check how much is converted into steam. There was 100 gram of water, and when the water started boiling, then we have 95 gram of water left. It means that the 5 gram water has converted into steam. Do you understand this idea?
Yes, sir.
Okay, so 5 gram of water has converted into steam. So whenever there is a state change, and if you want to calculate the heat, the formula is very simple. Heat equals m multiply L, where m stands for the mass of the liquid which converted into other state, and L is the latent heat, specific latent heat. Let me check what is the specific latent heat. Okay, the mass of the water heat is equals to m multiply L. The mass is 5 gram, and the specific latent heat of vaporization of water is 2250 joules per gram. Just put these values, multiply with each other, and get the answer.
Sir, mass is 95 grams.
No, the mass is not 95 gram. The mass is just 5 gram. We are taking that mass which has converted into gas. There was 100 gram water, and now there is only 95 gram water. It means 5 gram water has converted into steam. You understand this thing?
Yes, sir.
Okay, just multiply them, get the answer.
11,000 11,250 joules.
Okay, so that much heat is used for converting it into the steam. Okay, so the next part. His question is, he says the amount of heat produced by the heater that is not transferred to the water. How much heat was produced by the heater? That was the first part. What is that answer? What if Muskan checked the answer?
24,000 joules.
From that, subtract the heat which was used to raise the temperature. That was second part. And also subtract the heat which was used to convert the water from into the steam. From the heat produced by the heater, subtract the heat which was used to raise the temperature, and also subtract the heat which was used to convert the water into steam, and you will get the heat which got wasted and which was not given to the water. The marking scheme is also showing on your screen.
Four thousand 350 joules.
Yes, that is good answer. So, Muskan, do you understand the idea of this whole story?
Yes, sir.
This whole numerical, do you understand this?
Yes, sir.
Okay. Never forget this story, okay? So this was question number 10. Now we are on the question number 11. A student makes a model of an atom. The model contains 24 electrons, 25 protons, and 26 neutrons. Some of these particles are inside a nucleus at the center of the model. Determine the nucleon number of the atom. So what will be the nucleon number? Nucleon number is proton plus the neutrons. So it will be 25 plus 26. 51. Nucleon number will be something like 51. Muskan, you're done with the first part? Hello?
Yes, sir. 51.
Okay. The second part is explain why the model represents a charged atom. You see, it has 25 protons and there are 24 electrons. So the positive charge is 25 and the negative charge, the negatively charged element, or you can say the protons are positively charged, so they are 25, and the electrons are negatively charged, they are 24. So there is one more proton as compared to electron, so it will be positively charged. It's a 2-mark question. So your argument should be more proton than electrons or different number of protons, electrons. Positive and negative do not cancel out completely because there is one more proton. You can't write this answer. Marking scheme is also showing on your screen. Muskan, are you done?
Done, sir.
Read your answer.
I have written that there is one more proton than electron. Then I have written the second point that electron have negative charge on them and proton have positive charge, and negative and positive charge do not cancel out.
Because there is one extra proton there. The third part is the student makes a new model of a different isotope of the same element. Describe the nucleus of this new model. Okay, the nucleus of this new model will have same number of protons, but the number of neutrons will be different. Isotope means they will have the same number of protons, but the number of neutrons will be different. So the new model will have 25 protons, but the number of neutrons may be 27, maybe 28. maybe 25, not 26. The marking scheme says 25 protons, but a different number of neutrons as compared to the first model.
I have written that new model will have 25 electrons and number of neutrons will be different.
What you said, 25 electrons?
Yes, sir.
No, we are talking about the nucleus. Electrons are not in the nucleus. He says, describe the nucleus of the new model. Cut this word electrons. Electrons are not inside the nucleus. Instead
Sir,
of electrons, write protons. Now read your answer again.
new model will have 25 protons and number of neutrons will be different.
Okay. He says the B part, americium 241 is radioactive. Its nuclide notation is americium 94 241. Determine the number of neutrons in the nucleus of the americium 241. The number of neutrons can be found by 241 minus 94. 241 minus 94. Get the answer.
147.
140. So there will be 147. There will be 147 protons. Oh, sorry, neutrons. A nucleus of americium 241 emits an alpha particle and decays to uranium 235. Complete the nuclear equation of the decay of americium 241. You see, whenever an alpha particle is given out, on the top of the alpha particle, its mass number is 4. So on these dotted lines which are on the top of the alpha particle, you will write 4. Its proton number is 2. So in this bottom dotted line with the alpha particle, you write 2. Whenever an alpha particle is given out, the mass number decreases by 4 and the proton number decreases by 2. So from 94, it will decrease to 92. From 94, decrease this by 2. So here it will become 92. Muskan, have you written your answer?
Yes, sir.
Okay. Let me show you the marking scheme as well. Alpha has a mass number of 4. Alpha has a proton number 2. Correct proton number for you, that will be 92. Okay, so we are moving to the next part. Let me reduce the size. He says, Geiger and Martson studied the structure of gold atoms. Figure 11.1 shows a version of their apparatus. Alpha particles strike a thin gold foil. The apparatus shown is in a container from which all the air is removed. Suggests why it is necessary to remove all the air from the container. Because you see, you are using alpha particles. The penetration power of the alpha particles is very low. If the air is present, the alpha particles can only penetrate few centimeters, maybe 5 or 4 centimeters in the air. Because the alpha particle size is large, their penetration power is low, because they have high ionizing power, so they will be stopped by the air molecules. So it's very important that you remove all the air which is inside that container, so that the alpha particles can reach the gold foil and they can also reach the detecting screen. Muskan, do you understand this idea? It's a 1 mark question.
Yes, sir.
Okay. So it says, see, the answer is on your screen. The alpha particles only travel a short distance in the air, or you can say alpha particles stopped or scattered or deflected by the air if the air is present, or alpha particles ionize air. If the air is present, they will start ionizing the air, which will stop the alpha particles. Just write your answer.
Done, sir.
He says the alpha particles are emitted from the source at random. Explain why most of the alpha particles from the source do not reach the gold foil. The reason is they are emitted in all the directions. But the slit which is in the detecting screen around the gold foil, that is a very small slit. And the alpha particles are going in all directions. They are they are given out not in just in the direction of the slit, but in other directions also. So only few alpha particles are going in that direction. It's just a common sense question. You see, particles come out off in different directions, or not emitted in one line as a ray, or not all the particles pass through the slit. Gee, Muskan, do you understand? The alpha particles from this source are given out in all the directions.
Yes, sir.
Very few alpha particles or some of the alpha particles are going in the direction of the slit. So kindly write your answer. We would like to hear it.
I have written that alpha particles are moving in all directions, so only few of them are going to pass through from slit.
Instead of saying moving, underline that word moving and write emitted. So now read your answer.
Alpha particles are emitted in all directions, only few of them are going to pass through slit.
Only few of them are going in the direction of the slit. Okay, it's good. Now the next question. It says figure 11.2 shows a model of an atom of the gold foil with its nucleus at the center. He says the alpha particle labeled A is deflected by the nucleus as shown. On figure 11.2, complete the path of the alpha particle labeled B. Okay, let me copy it from here. And let me copy it. Okay. So now we have to show. We'll take a okay. Because this is the alpha particle B. The alpha particle is positively charged. The nucleus is also positively charged. So they have repulsion with each other because the distance between the alpha particle B and the nucleus is smaller as compared to the distance between the alpha particle A and the nucleus. So the alpha particle will be experiencing a larger force of repulsion. So this is the way in which it will be deflected. You see, the reason that why it will be deflected more is because this alpha particle is nearer to the nucleus as compared to the alpha particle A. So it will be experiencing a larger force of repulsion. Alpha particle is positively charged, the nucleus is also positively charged, and they are repelling each other. Muskan, do you understand?
Yes, sir.
Muskan, did you get this point?
Yes, sir.
Hello?
Yes, sir.
Okay. Your voice is very low. I'm not able to hear it. But anyway, so we are moving to the next part. Explain how the alpha particle scattering experiment provide evidence for the existence of a small nucleus inside the atom. You see, try to understand this point. This is a 3-mark question. In this experiment, this one, you see they bombarded a very thin gold foil with alpha particles. Most of the alpha particles passed straight, undeflected. Most of the alpha particles passed straight, undeflected. Um, some of the alpha particles were deflected at larger angles, and very few alpha particles bounced back. You see, 3 things happened. Most of the alpha particles went straight through the gold foil as if there is nothing in their path. Very few alpha particles were deflected at a larger angle, and very few alpha particles were deflected backward, which means from here they concluded that the atom is mostly empty space. There's nothing in the atom. The most of the space in the atom is empty. That's why most of the alpha particles went straight undeflected, and very few deflected at a larger angle. From there, they concluded that there is a nucleus inside an atom, and that nucleus is very small, and it has a positive charge. Very few deflected at larger angle, and very few bounced back. The very few alpha particles bounced back. From here, they concluded that the most of the atom is empty, and there is a nucleus, a very small nucleus in an atom, and that nucleus has mass and it has positive charge. So from their experiment, they concluded these 3 things. So let me show you the marking scheme, which is showing on your screen as well. He says this is a very important experiment. Geiger and Marson experiment. Particles close to fired and the nucleus are deflected or back or repelled. Some particles pass straight through. A few particles come back. Larger deflection of most pass straight through with little deviation. And how this explains the nucleus is small. You see, most of the alpha particles went straight. Some of the alpha particles were scattered or deviated at a larger angle, and very few alpha particles were deflected back. From here, from these points, they concluded that most of the atom, the space is empty, and there is a small nucleus inside the atom who has all its mass and all its positive charges in that nucleus. Muskan, will you able to write this answer? So I think the Muskan has some internet problems, so she is no more with us. So, my dear students, you can write your answer. This is a 3-mark question, and there you can see 1, 2, 3, 4, 5, 6, 7, 8 lines are given for this answer. 8 lines are given for this answer. It's a 3-mark question that explain how the alpha particle scattering experiment provides evidence for the existence of a small nucleus inside the atom. You see, the most of the alpha particles went straight through the gold foil undeflected. Some of the alpha particles were deflected at a larger angle, and very few alpha particles were bounced back. From here, they concluded that most of the atom is an empty space, has empty space. There's nothing in it, and some of the alpha particle, and there is a nucleus, and the size of the nucleus is very small as compared to the size of the atom, and all the mass and the positive charge is in that nucleus. So these are the conclusions they made. I hope you will be able to write this answer. So, my dear students, by this question, we have reached the end of this paper. Today, today is 26th February 2021. I was with the 11 Cambridge class. Today we have done in this session May June 2052 one paper. It's a zone 1 theory paper, paper 2. And in this session we have only attempted the section B of this paper. In this section B we have question number 9, 10 and 11. So I have tried my best to explain it to you that how the answers are written. We have also compared it with the marking schemes, and I hope that this will be very helpful to you, and your grades will improve. So thank you very much, everybody, and have a good day. And God bless you all.